Hello, welcome to the demonstration of data analysis. So here we have some trip data for taxi, and we take those data in Python using Pandas. And here we can see we check the data to get an understanding of the data for all of the 3 months using head and tail. And then we use describe function to see some stats for each of the data sets to get a better understanding, see the mean and especially mean and median. And then we take the length for each of these data sets for January, March, and June. So this length is basically the count of the writes, and we can see that January has lower write count compared to the other 2 months. And moving on, we use the info to see some more information, especially the data type for each of these columns. And then we want to check to see how much people are coming in through the airport. And for that, we calculate the percentage of people, percentage of writes that are from the airport using the airport fee column, and we see that in June it is the highest. And then we want to handle the missing values, so we see that there are a lot of null values here, and none of the fields seem logical to replace the null values with a mean or anything else, so we simply remove those using dropmap. And then noisy values, there could potentially be even more noisy values than what is covered here, but for this demonstration I am looking at the pickup date time, and I set the valid start time and the valid end time, and then I take the values as a clean data set within that fall within the valid time, and I then check with the original, compare, and find out the noisy data. And when I do that, I find out that there are 48 rows that existed with noisy data. And if you look at the noisy data, you will see that some values are outright false, like 2008 or something. And there are some values that are coming in from December 2022. But from the context, in the context of this particular dataset that only deals with the trips from January, I think it is not worthwhile to keep any of these data that had a pickup time before January, start of the January. So we remove those. We already did that here using the thing. And then I also want to check the rate code. And according to our data dictionary, this 99 value, it is not defined. And thus, I consider it an invalid value. So we remove this as well. So we remove all the rows that has 99. Now for the correlations, we can simply use the core function to get a correlation matrix like this. And from the top of the looking at it at a glance, we can see that the PR amount and total amount are very highly correlated with almost a value of 1. This is because the total amount and PR amount are within total amount contains the PR amount, and the PR amount is the biggest chunk in the total amount. Now moving on to creating rush hour flag, and we can see we use this method called day of week. And what it does is it returns 0 to 4 for Monday to Friday, and Saturday and Sunday it returns 5 and 6. Based on that, we can say that if it is less than 5, then it is yes, and we say the column name is weekday. So weekday is yes if it is less than 5, otherwise it is a weekend. And then we move on to creating our rush hour flag. We can do this two ways. One is using a function, first creating a function and then applying that function into the data frame. But we don't do that here, and I'll explain the reason later. But here, what we do is we take a time and convert it all into a seconds. And we also set some time for what we consider to be the rush hour. And this is arbitrary time I set by looking on online and stuff. So the rush hour is 6 a.m. to 10 a.m. and 4 p.m. to 8 a.m. And for weekends, the rush hour is 7 p.m. to 10 p.m. So this is why we created the I guess we created something here, the weekday. So we created that for calculating the weekend stuff. So we create 3 conditions and we check if none of the conditions meet, then it is not rush hour. If one of the conditions meet, then it is in the rush hour. And now for the complexity feature, we go to the taxi zone shapefile, which is we import it using we take it using the Geopandas, and we take a look here. One thing to note here is that the values range from 0 to 1 to 0 to 262. This is important because later on we don't want any values that are not present in this Geopanda dataset. So we only take data of location between 0 to 262, and we don't care about the others. And we also use the centroid function that is built in, comes with the Geopandas, to create another column there for the centroids. And now what we do is simply check that the location for the 2 data frame are the same type. Then we take the centroid X and Y. Then we mark the data set firstly using the pickup location ID and kind of like a left join. And then we do with the drop off location ID with similarly left join. And once we merge this, we can simply do Euclidean style of calculating the distance between x and y, the 2 points, and we get that in this column. And then we simply put that column into our original data set. With that, we have the data values, and here what we do is simply convert the data that is of this straight distance, which came in meter, to the miles. And we also take values that are greater than 0, because we are going to divide later on, and we don't want 0 here. And we then create a complexity, and which is basically the formula is that straight distance by trip distance. That is our value for the complexity, and we see some values coming here. And then for the frequency of taxi, we simply use value counts. When you do normalize, we basically get proportions instead of counts, and then we multiply it by 100 and get percentage. So for example, for the zone 237, 4.9% of the pickups are from here. Similarly, we do this for the drop off. We see that the vendor, which is the, I guess, called the Verifone is by far the most popular vendor. And then for peak travel hours, we take the hour from each of the data rows, and we simply use value counts to get the value for each of the hours, hour values, and we show the top 4. So the top 4 ends up being 18, 17, 15, 16. So these are the basically 4 p.m. to 8 p.m. is the peak travel hour. Now for the average distance of weekday and weekends, we already have the weekday here, and we'll just do a trip distance group by, and we take the mean of trip distance. When we do group by, we get 2 values, one for y, one for n. And similarly, we do the same for passenger count. And here we can see that the correlation between fare and tip, we can see that there is some correlation in the scatter plot, and we also saw that the correlation matrix had around 0.7. So there is a bit of correlation here, but we can also see that there are some negative values, and we'll talk about it later. For the correlation of fare and number of passengers, we have we use box plot, and we see that for values from 0 to 6, the data is fairly similar, but for 7 and 8, there is an increase. So for trips with 7 or more passengers, the trips tend to be more expensive, probably because it requires a more expensive vehicle. So based on those, we do some of the stuff writing here, and we talk about some of the stuff I said before, like for example, the negative values in the fares, and it could be due to some sort of business logic. So I kept it here, but we can also just remove those as well. And yeah, so the method I used for the featureization, I did not use the data frame.apply because this takes way long to finish. That's it. Thank you very much.